Good morning, it's your stats sensei, Mr. Spensei, and this is a confidence interval on harvest time for a tea distribution. So, the Ministry of Agriculture is interested in examining possible changes in the time to harvest in a region where it's been introduced. Past studies suggest that under similar conditions, time to harvest is 100 days and is normally distributed. Ooh, that's important. Normally distributed. To examine whether the mean time to harvest has changed, the researcher collects data from a random sample of 15, so we know our sample size is 15, to examine whether the mean time to harvest has changed. And they have more than 3,500 fields, so we have a big population that were planted with sorghum. The results are as follows. Well, create a 95% confidence interval for the mean time to harvest. Well, we know it's going to be x bar plus or minus t star s divided by the square root of n. Let's start off by calculating that t star. Well, t star is going to be inverse t, 1 minus 0.95 divided by 2, and the sample size minus 1. So let's go ahead and do that real quickly. So second vars, inverse t, parenthesis, oops, parenthesis, 1 minus 0.95. Close the parenthesis, divide by 2. Degrees of freedom is our sample size minus 1. And I end up getting 2.1447. Please go ahead and make that positive. Also at this time, we should enter that data in the calculator, all of it. So we have stat edit. We've entered all of our data into stat edit, and there it is. Then I'm going to go stat calc, one variable statistics, blue one if you have something else. And there's my sample mean, and there's my sample standard deviation. And because we're working with a sample standard deviation, that's why it has to be a t distribution. So I can go ahead and plug all that information into my formula. So 107.6666, that's my sample mean. The t star, we calculated it above. My sample standard deviation, 8.1034, and my sample size of 15. All right. So recording that important information, there it is. And there's my degrees of freedom. And please don't forget, degrees of freedom has a very simple formula. At least for one sample, it's just n minus 1. All right. Next, we are centered on our x bar. All right. So we're centered on 107.666. And this area right here is 97%. And ultimately, we're going to have a lower and upper bound. Well, we're going to do a one sample t interval. All right. And I'm going to go ahead and calculate it since I have all that information. Stat test. And we're going to drop down to number 8, which is t interval. Our information is in our data. And we want to calculate a 95% interval. So 0.95. And I get a lower bound of 103 days to an upper bound of 112 days. And the very fact that it had been 100 days, it seems like it's now taking longer to go to harvest. All right. Somewhere between 3 days and 12 days because it was 100 days. So now 100 is not in there. So 100 is not a reasonable estimate anymore. So let mu equal the true population mean amount of time to harvest for sorghum. Okay. Conditions. Well, they told us we had a random sample of 15, and that was given to us. That was so nice of them. All right. Our sample size is 15, and 15 times 10 is 150. And we had 3,000 and we had 3,500 fields. So N is less than 10% of the population. Now, 15 is not greater than 30, so it's not normal by central limit theorem. But fortunately, they told us our data was normal, so normal distribution was actually given to us. All right. So in conclusion, we are 95% confident that the true population amount of mean amount of time to harvest sorghum lies within our interval that we calculated. And in repeated sampling, we expect this method to capture the true population mean amount of time to harvest sorghum 95% of the time. So our method is so good that 95% of the time it captures it. All right. Appreciate you watching. Look forward to seeing you on the next one. Thank you.